For eons, humankind has looked at the stars, trying to understand our place in the universe, wondering about distant stars and galaxies. With current technology, we are now able to explore further and more detailed than ever. With the Gaia Space Observatory, the European Space Agency aims to create the most accurate and complete multi-dimensional map of our astronomical neighbourhood, the Milky Way. A truly Herculean and groundbreaking endeavour.
Gaia is a wonderful mission which is intended to look at the stars, determine their position, motion, and their astrophysical parameters, their ID card in some sense.
So it is a big database containing the information on how the galaxy move and what the galaxy is made of. And with the help of theoretical model, we will be able to reconstruct the past, the history of our galaxy, and also predict its future.
Now the mission has passed another milestone with a third full data release, after two earlier releases in 2016 and 2018. With each new release, the observed stars, solar system objects, and extragalactic objects increase, and more details are added to what is already the most detailed overview of our galaxy. New in this data release are spectra for a significant number of these stars and other objects, which can be used to accurately determine luminosity, temperature, mass, and chemical composition. Another important feature in the Gaia catalogue is the inclusion of the radial velocity for over 33 million stars, a 5-time increase compared to the previous data release, and the largest radial velocity survey to date. Radial velocity is important, as it tells us how fast stars are moving away from us or moving towards us.
The radial velocity is the velocity of the star along the line of sight, while the tangential velocity that is obtained from the astrometric measurement tells you how the star moves in the plane of the sky. So the combination of the radial velocity with the tangential velocity provides the three-dimensional information on the star velocity.
This new data release also contains, for the first time, information on multi-star systems when two or more objects are orbiting one another. This information was obtained by using all three observing techniques of Gaia: astrometry, photometry, and spectroscopy. As a result, this Gaia data release sees the inclusion of the largest catalogue of binary stars in our galaxy. The catalogue of these stars is crucial for understanding stellar evolution, and this surpasses all the work that's been done on binary stars in the last 2 centuries. Binary stars are also important to determine the mass of a star and to discover exoplanets.
In general, you can determine the mass only when you have a binary system. When the object is single, you need to rely on a model for that. When it's binary, then you get the precise mass of the two components if you have enough information. So it's a way to determine it observationally. It's not a model. It's an observation, so it's much more precise than what you can infer from stellar physics.
With this new data release, Gaia is once more proving its worth, helping us to understand our galaxy and pointing out new areas for scientists to research.
The Gaia data is, I would say, a silent revolution, because now you get information about the stars for hundreds of million stars that no one could have dreamed before.
Gaia is an example of collaboration between ESA, European institutions, and over 400 scientists. They will soon already be working on the next data release, providing ever more observations and data coming from the Gaia mission, moving in sync with our planet as it scans the heavens.